sklearntreeExtraTreeRegressor. Description: ExtraTreeRegressor is an ensemble learning method that combines multiple decision trees to improve prediction accuracy and reduce overfitting. It utilizes the extremely randomized trees algorithm, which introduces randomness at both feature selection and threshold selection during tree construction. This approach leads to more diverse and robust trees, effectively mitigating the impact of noisy data or outliers. Inputs: XA2D array representing the training data, where each row corresponds to a sample and each column represents a feature. YA1D array representing the target values for each training sample. Outputs: predictions, the predicted values for new data points. Fitted model, a trained ExtraTreeRegressor object, which can be used to make predictions on unseen data. Steps: tree construction. Multiple decision trees are constructed using the extremely randomized trees algorithm. For each tree, random subsets of features are selected at each node, and random thresholds are used for splitting the data. Aggregation: predictions from individual trees are aggregated by averaging or voting, depending on the chosen strategy. Metrics: mean squared error MSE measures the average squared difference between the predicted and actual values. R squared R2 represents the proportion of variance in the target variable that is explained by the model. Visualization plots: decision tree visualization. Each individual tree can be visualized to understand the decision-making process. Feature importance plot shows the relative importance of each feature in the model's predictions. Fine-tune parameters: estimators the number of trees in the ensemble. Increasing this value usually improves accuracy but can lead to longer training times. Max depth: the maximum depth of each individual tree. Limiting depth can help prevent overfitting. Min-sample split: the minimum number of samples required to split an internal node. This parameter controls tree complexity. Random state: an integer for initializing the random number generator. Setting this value ensures reproducible results. Uncertainty methods: bagging: the ensemble nature of ExtraTreeRegressor inherently introduces uncertainty in the predictions. Feature importance: the feature importance scores provide insights into the model's reliance on specific features. Challenges and fixes. Challenge 1: overfitting to noisy or sparse data. Sample use case: training a model on a dataset with a large number of irrelevant features or noisy data points. Fixes: use a smaller number of estimators to reduce the complexity of the ensemble. Adjust the max depth parameter to limit the depth of individual trees. Consider using a data preprocessing technique, such as feature selection or dimensionality reduction, to remove irrelevant or noisy features. Challenge 2: long training times for large datasets. Sample use case: training a model on a very large dataset with a high number of features and samples. Fixes: use a smaller number of estimators to reduce the computational cost. Consider using a parallel processing library to speed up the training process. Employ techniques such as early stopping or gradient boosting to reduce the number of training iterations.